Today we are solving remove elements problem. If you have watched my last video, we were solving remove duplicate elements. It was very similar to this problem. In this problem, again we have one integer array, and we need to remove given element from the array, and we need to do it in place, which means we cannot create a new array. We need to use the same array, and we can replace elements places and swap elements, but we cannot create new array. And if you see, we cannot use extra memory, so we can only use big of one space. And and we'll solve this problem in big of n time complexity. So here there is very important thing to note is the array is not in sorted order, and we can return array in any order, so it doesn't need to be sorted. So that is a really good hint, and using that hint we can solve it in two ways. So both of the solutions are two-pointer solutions, and we'll use both solutions, and I'll show you how we can use two different solutions or two different two-pointer methods to solve the same problem. Before we go to the solution part, let's check the companies. Oh, it's not a popular question. Only Adobe and Amazon is there. Okay, so let's go into the solution part. So as I mentioned, we have two different ways to implement two-pointer solutions. One is turtle and rabbit solution, where we will have two pointers, and one will move slow and another will move faster, and that's why turtle and rabbit solution. And there is another solution which is left and right two-pointer solution. So in that case, we will have two pointers at two ends of an array, and it will come closer until we get the final solution. So we will start with the turtle and rabbit solution, or slow and fast pointer solution. So for that, I will have one pointer called slow, and I will have one for loop, and we have one pointer fast, and we'll check until fast is less than num.length, and fast plus. And we'll check whether the current element should not equal to the value, and if it's not equal to the value, then we'll just swap, not exactly swap, but we will put the value of fast pointer to the slow pointer, and we'll just increment slow pointer, and at the end we can return slow. Okay, so we can do so it ran successfully. So let me explain it little bit in deeper way. So for example, let's say I is the slow one and J is the fast one, and we want to remove number 2 from this example. So initially what will be the case is I will be here and j will be here, okay, and j is the fast pointer. So generally the fast pointer checks and verify the conditions and validation and all those things, and the slow pointer is the place where we write something or update something, okay, and it's same here. So the fast pointer will check whether the current element is number 2 or not, the element which we want to remove, okay, and if it's not 2 then it will paste the current value to the slow pointer, but here I and j are pointing to the same element, so we will go ahead and I will also go ahead. Again the same condition, numbers of j is equal to 1 and it's not equal to 2, then we will put j's value to the ith index, and we will increment j, we will increment I. Now here is the catch. So here nums of j is equal to 2, which means we will not fulfill this condition and we won't do any of these things, and we'll simply increment j. So here we are not incrementing I, we are just incrementing j, and that's why j is the fast one and I is the slow one, because here j will go ahead. Again j saw that the current element is number 2, so again we won't do anything and we'll simply increment j. Now this time we saw that numbers of j is not equal to 2, so we will put jth value to ith index, so we'll put it here, we will increment I, we will increment j. Again j is not equal to 2, so we will replace ith value with the jth value, increment I, and we'll increment j. Again the same condition, so we'll put it here and increment I, increment j, and here we saw that j is equal to 2, which means we don't need to do anything, and we'll increment I, and now j is greater than numbers of dot length, so we'll return I. So when we are returning I, this is our solution, so we are one step ahead of our solution, so we can simply return I, which will be the size of our solution, right? So our solution size is 1 2 3 4 5 and our ith value is 5, so we can return the 5 and this will be our solution. So this is one way of solving it. Let's try submitting it. Okay, now there is another solution which is again 2 pointer solution, but it is kind of left and right solution. So again we'll take let's say this time we can take left. Let's delete this code, and integer right is equal to numbers dot length, and while left is less than right. So as I mentioned, the 2 pointers will be at 2 opposite points. So again let's take this example. Let's say L is equal to left and R is equal to right, and again we want to remove number 2, right? So initially here will be L and I will be somewhere, sorry, R will be somewhere here, and until left is less than right, it means until these two meet, will keep coming closer. So here I will first check if numbers of left is equal to value or not. So if left is equal to value or not, if it's a value, I mean if it's the element which we want to remove, then we'll just swap uh, these values. So what we can do is numbers of left is equal to numbers of is equal to numbers of right minus 1. So if you see, I initialize it with the numbers dot length, so I need to do minus 1 for it. So it means now left's value is the value of the rightmost element, because we just want to remove the 2's, right? We just want to remove the 2's and we don't care what we are putting here, but we just need to make sure that it's not 2. Okay, and after removing it, we'll decrement right. Okay, and else it means the current element is not the value which we want to remove, then we can simply increment the left, and at the end we can return right. In the explanation I will explain you why we are returning right here. So let's take this example. So here first of all I check that left should be equal to the value we want to remove. If it's not that, we'll simply increment left. Again it's not equal to 2, we'll simply increment left, and this time we saw that left is equal to 2. So what we'll do is we will place the value of r minus 1, which is 2, to the or left position, and then we will decrement right pointer. Okay, and in the next iteration I again came here, and this time I saw that left is again 2. So this time again I will replace right minus 1th position to the left, which will be 4, and will decrement right. Now this time we came here, left is not equal to 2, we'll increment left. Again we came here, left is equal to 2, then again we'll replace it with the 0, and we'll decrement right. And then we again came here, left is not equal to 2, we can simply increment it. Left is again not equal to 2, we can increment it, and this time this condition will not fulfill. Left is not less than right, it is actually equal to right, and we can just return right. Here right's value is 5, which is the size of our solution, so we can return right, or in this case we can also return left. Okay, let's try to run it. Okay, and let's submit it. So if you see, this actually improved our time complexity, and the reason is this will work better when we have less elements to remove from an array, and The reason is, in the slow and fast pointer you are doing lots of copy and paste work, and many times that was not necessary. But in this solution we are doing it only when it is needed, so we are reducing our work, and that's why you are seeing the improvement in the time complexity. That's it for this video. If you like this video, please like, share and comment. If you have better solution, let me know. I'll be happy to learn. And if you have any questions, please put it in comments. I'll surely explain you. Yeah, and see you in the next video. Thank you. Bye.